Please welcome to the stage Nvidia founder and CEO, Jensen Huang.
This is Earth 2. The idea that we would create a digital twin of the Earth, that we would go and simulate the Earth so that we could predict the future of our planet to better avert disasters or better understand the impact of climate change so that we can adapt better, so that we could change our habits now. This digital twin of Earth is probably one of the most ambitious projects that the world's ever undertaken, and we're taking large steps every single year, and I'll show you results every single year, but this year we made some great breakthroughs. Let's take a look.
On Monday, the storm will veer north again and approach Taiwan. There are big uncertainties regarding its path. Different paths will have different levels of impact on Taiwan.
In the late 1890s, Nikola Tesla invented an AC generator. We invented an AI generator. The AC generator generated electrons. Nvidia's AI generator generates tokens. Both of these things have large market opportunities. It's completely fungible in almost every industry. And that's why it's a new industrial revolution. And now we have a new factory, a new computer. And what we will run on top of this is a new type of software. And we call it NIMs, Nvidia Inference Microservices. Now what happens is the NIM runs inside this factory. And this NIM is a pre-trained model. It's an AI. Well, this AI is, of course, quite complex in itself. But the computing stack that runs AIs are insanely complex. When you go and use ChatGPT, underneath their stack is a whole bunch of software. Underneath that prompt is a ton of software. And it's incredibly complex because the models are large, billions to trillions of parameters. It doesn't run on just one computer, it runs on multiple computers. It has to distribute the workload across multiple GPUs, tensor parallelism, pipeline parallelism, data parallelism, all kinds of parallelism, expert parallelism, all kinds of parallelism, distributing the workload across multiple GPUs, processing it as fast as possible, because if you are in a factory, if you run a factory, your throughput directly correlates to your revenues. Your throughput directly correlates to quality of service, and your throughput directly correlates to the number of people who can use your service. We are now in a world where data center throughput, utilization is vitally important. It was important in the past, but not vitally important. It was important in the past, but people don't measure it. Today, every parameter is measured. Start time, uptime, utilization, throughput, idle time, you name it. Because it's a factory. When something is a factory, its operations directly correlate to the financial performance of the company. And so we realized that this is incredibly complex for most companies to do. So what we did was we created this AI in a box, and it contains an incredible amount of software. Inside this container is CUDA, cuDNN, TensorRT, Triton for inference services. It is cloud native so that you could auto scale in a Kubernetes environment. It has management services and hooks so that you can monitor your AIs. It has common APIs, standard APIs, so that you could literally chat with this box. You download this NIM and you can talk to it. We now have the ability to create large language models and pre-trained models of all kinds. And we have all of these various versions, whether it's language-based or vision-based or imaging-based, or we have versions that are available for healthcare, digital biology. We have versions that are digital humans that I'll talk to you about. And the way you use this, just come to ai.nvidia.com. And today we just posted up in Hugging Face the Llama 3 NIM, fully optimized. It's available there for you to try. And you can even take it with you. It's available to you for free. And so you could run it in the cloud, run it in any cloud. You could download this container, put it into your own data center, and you could host it, make it available for your customers. We have, as I mentioned, all kinds of different domains. Physics, some of it is for semantic retrieval called RAGs, vision languages, all kinds of different languages. And the way that you use it is connecting these microservices into large applications.
Great to be in Taiwan. Before I head out to the night market, let's dive into some exciting frontiers of digital humans.
Imagine a future where computers interact with us just like humans can.
Hi, my name is Sophie, and I am a digital human brand ambassador for Unique.
This is the incredible reality of digital humans. Digital humans will revolutionize industries, from customer service to advertising and gaming. The possibilities for digital humans are endless.
Using the scans you took of your current kitchen with your phone,
They will be AI interior designers, helping generate beautiful, photorealistic suggestions and sourcing the materials and furniture.
we have generated several design options for you to choose from.
They'll also be AI customer service agents, making the interaction more engaging and personalized. Or digital healthcare workers who will check on patients, providing timely, personalized care.
I did forget to mention to the doctor that I am allergic to penicillin. Is it still okay to take the medications?
The antibiotics you've been prescribed, ciprofloxacin and metronidazole, don't contain penicillin, so it's perfectly safe for you to take them.
And they'll even be AI brand ambassadors, setting the next marketing and advertising trends.
Hi, I'm Ima, Japan's first virtual model.
The AIs connect to another generative AI to dynamically animate a lifelike 3D mesh of a face. And finally, AI models that reproduce lifelike appearances, enabling real-time path-traced subsurface scattering to simulate the way light penetrates the skin, scatters, and exits at various points, giving skin its soft and translucent appearance. Nvidia ACE is a suite of digital human technologies packaged as easy-to-deploy, fully optimized microservices, or NIMs. Developers can integrate ACE NIMs into their existing frameworks, engines, and digital human experiences. Nemotron SLM and LLM NIMs to understand our intent and orchestrate other models. Riva Speech NIMs for interactive speech and translation. Audio to face and gesture NIMs for facial and body animation, and Omniverse RTX with DLSS for neural rendering of skin and hair. ACE NIMs run on Nvidia GDN, a global network of Nvidia accelerated infrastructure that delivers low-latency digital human processing to over 100 regions.
We had the good wisdom of including Tensor Core GPUs in all of RTX. So we've been shipping AI GPUs for some time, preparing ourselves for this day. The reason for that is very simple. We always knew that in order to create a new computing platform, you need an install base first. Eventually, the application will come. If you don't create the install base, how could the application come? And so if you build it, they might not come. But if you don't build it, they cannot come. And so we installed every single RTX GPU with Tensor Core processing, and now we have 100 million GeForce RTX AI PCs in the world, and we're shipping 200, and this ComputeX, we're featuring 4 new amazing laptops. All of them are able to run AI. Ladies and gentlemen, this is Blackwell. Blackwell is in production. Incredible amounts of technology. This is our production board. This is the most complex, highest performance computer the world's ever made. This is the gray CPU. And these are, you could see each one of these Blackwell dies, 2 of them connected together. You see that? It is the largest die, the largest chip the world makes. And then we connect 2 of them together with a 10 terabyte per second link. Well, even so, it's not big enough. And so we have to build even larger machines. And so the way that we build it is called DGX. So this is our Blackwell chips, and it goes into DGX systems. So this is a DGX Blackwell. This is air-cooled, has 8 of these GPUs inside. Look at the size of the heat sinks on these GPUs. About 15 kilowatts, 15,000 watts, and completely air-cooled. This version supports x86, and it goes into the infrastructure that we've been shipping hoppers into. And so this is the MGX system, and here's the 2 Blackwell boards. So this one node has 4 Blackwell chips. These 4 Blackwell chips, this is liquid cooled. 9 of them, 72 of these GPUs are then connected together with a new NVLink. This is NVLink switch 5th generation. And the NVLink switch is a technology miracle. This is the most advanced switch the world's ever made. The data rate is insane. And these switches connect every single one of these Blackwells to each other, so that we have one giant 72 GPU Blackwell. Well, the benefit of this is that in one domain, one GPU domain, this now looks like one GPU. This one GPU has 72 versus the last generation of 8, so we increased it by 9 times. The amount of bandwidth we've increased by 18 times. The AI flops we've increased by 45 times, and yet the amount of power is only 10 times. This is 100 kilowatts, and that is 10 kilowatts. But our next generation platform is called Rubin. The Rubin Platform, I'm not going to spend much time on it. I know what's going to happen. You're going to take pictures of it, and you're going to go look at the fine prints, and feel free to do that. So we have the Rubin Platform, and 1 year later, we have the Rubin Ultra Platform. All of these chips that I'm showing you here are all in full development, 100% of them. And the rhythm is 1 year at the limits of technology, all 100% architecturally compatible. So this is basically what Nvidia is building, and all of the richness of software on top of it. Robotics is a much more pervasive idea. Of course, when I say robotics, there's a humanoid robotics that's usually the representation of that. But that's not at all true. Everything is going to be robotic. All of the factories will be robotic. The factories will orchestrate robots, and those robots will be building products that are robotic. Robots interacting with robots, building products that are robotic. Well, in order for us to do that, we need to make some breakthroughs, and let me show you the video. There you go. About my size.